Here it is, the Raspberry Pi dog monitor. This dog monitor is set up to monitor the dog by using the wheels for movement, for pivoting, for following the dog using IR, etc. Using a camera to not only use the IR to work in low light, but to take video of the dog and keep it stored so that it can be viewed later. Alongside this it's in a nice cardboard box chassis, with tape and glue being used as the primary method to hold it all together and to keep things in place. And that is so that the dog does not just see something electronic and either get scared or get excited, as my dog happens to do whenever he sees or hears anything that is electronic, like a vacuum cleaner, hearing a lawnmower or anything of the sort, and it's meant to take that to the lowest possible extent by making it out of cardboard rather than a different material. Inside, we have 2 battery packs, and of course a box for the Pi with the camera sticking out of it. We have, alongside those 2 battery packs and the Pi, 2 motor drivers, which lead to 2 motors that are on the outside, originally meant to be on the inside, but moved to the outside for stable movement, and wheels connected to those motors for things to run. Alongside this, we have a battery pack for the Pi itself. So, let's take a look at its functionality in movement. So, as you can see here, we have a nice box. Looks like it would be fairly movable. If we move the wheels around, it's generally stable in its movement. However, it fails to handle the load on even a hard surface, let alone carpet. This is because of the heavy battery packs and would probably work better without the quadruple D battery packs and better with something like a triple C battery pack. Unfortunately, quadruple D battery packs were the only things I had available to me, and I had to suffer the consequence of them being very heavy. However, upon lifting the dog monitor, if I were to start up the program here, and the camera tends to fall if lifted, that's not really too big of an issue, because it usually doesn't lift like that. But, yeah, we're doing it for this. And we take a look at the wheels. Some of them tend to run rather slowly, some of them tend to run rather fast. That's because of my securing methods used, but the wheels do in fact run. It's just that it cannot support the load that this chassis holds. Or rather the design of the chassis, and the inner chassis for the Pi. However, there are some upsides to this design, other than the quadruple D battery packs providing a lot of power, but having the downside of being too heavy. And that's that it's fairly open, so it's not too much of a clutter of wires as you'd usually see. And even better, if we turn this thing around, then you will notice that the Pi is not actually in a full box. The Pi is actually partly in a box, and this partial box has openings for all sorts of connectors. So, with this in mind, you can easily pull out the Pi, hook things up to it, etc., to be able to get the videos, to be able to add a program, and so on and so forth. I felt that was worthwhile design development, which is why I did not include this back panel here, so that could be easily removed. Otherwise, I would have had to create a flap of some kind, which would have been a little bit tougher using the cardboard. Alongside this, with it being such an open design, charging something like the battery pack for the Pi would not be nearly as hard as it would without an open design, considering that the charging port for this battery pack is right here, and that charging port would not be accessible under a closed design, but is fairly accessible under such an open design as this. Now, I'm going to show off the camera functionality. So, we are down to here to check out the attachment of peripherals, which you can see works fairly well between the monitor cord, actually working with the monitor, of course, and a mouse cord working with a nice mouse here. And I am also going to show off the video, as promised, by running this one here, this test 2, which shows off if the camera is working. Of course, to actually show off the recording function, it does not give a preview or anything of the sort, and because it cannot move around, it won't show much of anything rather than just a video like this preview will show. So, if we run this, we see me, hello. And that's basically, like, the camera functions very well. It is pretty dark down here, and the infrared is picking me up pretty decently. And while this cord is in the way, it usually would not be during the actual process of monitoring the dog. So, there you have it. It works with the video pretty well. The program for the dog monitor itself would not be all too useful without the wheels, unfortunately. So, this is the best way of showing off the camera functionality. And I'm going to go ahead and shut down the Pi. And there we go. And you can see that I have in here the little clicker to turn it on and off, just so that it makes it a little bit easier and does not cause too much harm to hear. Also, this was in nice and tightly, but when I picked up the whole box earlier, it jostled it a little bit and caused a bit of a problem. And now it is, well, now it's doing fine, but it was, yeah, and it would just flop over like that. So it just has to be nice and secure, and it will not fall over or anything. So, yeah, that is a partial design flaw, but not really anything too bad, as long as it is secure enough. And so that is both the wheels and the video. And for the state that this Pi happens to be in, this Pi project happens to be in, I'd say that it is fairly functional, but obviously it does not meet its goal of being a dog monitor unless it is a stationary dog monitor, while these cannot really even pivot correctly when the batteries are in, due to them being so heavy. It's quite a mass of batteries. So I want to move on to the final part of what really made my project for me. Like, what really made my project for me was not working on the wheels, was not working on the motor drivers or the Pi with the camera, or the program that I cannot even really make use of, but rather it stems from one of the most important things, and that is the learning process, the process that you go through to make something like this. When I came up with this idea, I thought, I don't want to use a kit. Kits are boring. That was slightly a mistake. Taking the easier route is not always taking the worse route, and I misjudged that a lot. I should have went with a simple dog monitor kit rather than building this cardboard abomination. Although the cardboard was a great idea for my dog, it would not have been, it was not stable enough alongside the wheels to support the batteries. As for the actual process of the project, though, as I went along and I figured out the camera first, it was not that tough to figure out how to get this camera working, how to get it focused properly, and how to get it to be able to look like a good display for monitoring the dog. I did have some troubles with the camera plugging into the Pi itself, but I fixed those relatively early on, in the first 2 weeks or so. Then we hit the virus, and we ended up home from school. And that caused quite a problem when it came to building this, because we were not allowed to access our materials, and I had wanted to order lesser battery packs than Quadruple D, but was not able to. In fact, these Quadruple D ones are battery packs of my own. If I had went for anything, it would have been a Triple C battery pack, which would have been a lot less weight and probably would have allowed the wheels to move easier. Alongside this all, though, we have the problem of just not being able to work on it in general. If I had been able to have those weeks, I feel like it would have went a lot smoother because I had my plan set up for those few weeks. And this problem of like the weeks not being too correlative to my original idea for a schedule, it really did screw up how I was going to focus on this project and how I was going to build this project. So that really, I really just didn't look ahead towards that and ended up getting caught in this whole mess of it being quite a problem due to the quarantine. And then we got all of our items, and I had one of my biggest problems, which shows more in my mentality rather than the actual physical part. Now, for those of you who may have been involved in the Raspberry Pi class and watching and viewing how everything went, you may have noticed that I used a Logitech wired mouse instead of my wireless classroom mouse. That is because I got the wrong classroom mouse nub to plug into the Pi. That it did not go with the keyboard and mouse that I had, and I could not pair it with them. And that ended up being a huge problem, and because I just really couldn't think of a workaround, despite the fact that I could have used my home keyboard and keyboard and mouse, because I do not use a laptop. I really did not think towards that until later on, and that really kept me from working on it for about a week. And that was my mentality, because I really thought that, like, I had problems earlier in the year with only one USB port being able to take an item, as the USB ports were rather finicky. And as it turned out, the USB ports actually all ended up being able to fit my home keyboard and mouse USB connector. So I was able to fit those two USB connectors in and continue with my work. From there, I got to work on one motor driver and one battery pack. And that did not work well with 4 wheels. It was not enough power, even with 12 volt. And I had to completely change up my plan and add in a whole other battery pack despite the fact that I thought one quadruple D would be able to be enough power for 4 wheels. It just was not enough. And then setting up the GPIO pins for these boards was not tough. And I just had to position this all as seen here with the 2 motor drivers nice and neat next to the Pi. The Pi box situated off to the side in a nice little corner area. The battery packs towards the back and front. And the battery pack for the Pi right behind the Pi and the motor drivers. And I thought that this was a very good design, and it really helped stabilize the weight. It still was not enough, though, as when I got to the wheels, things turned problematic. I went to build the box around the wheels, and as I built up the box using wood glue and the cardboard, as well as an X-Acto knife to cut it out, I realized that I would need a lip for the Pi to see over, and that is what this is. However, I had put it on the wrong side and realized that I didn't even need the lip after all. So I left that there, considering that it's just supposed to be a general cardboard box design. It's not supposed to be anything all too fancy, so small things like that would not matter. And I had the motors on the inside, and I thought that was perfect. That would be absolutely wonderful and would work great. However, they just weren't holding enough. So I consulted my dad, who works in technology and electronics as both an actual job and as a hobby, and he had told me to mount them on the bottom. And as you can see, I went and used some duct tape to really secure these to the bottom here, and to try and just generally have a nice area here where they're all sort of fit. And the more I used tape and the more I tried to glue these motors and the more all of that sort of went in succession, the more I realized that these motors just would not be able to sustain this box. And this went on for about, I'd say, a week and a half of work. And so I came to a conclusion just yesterday, just that this would not be a perfect idea, and that I should go with what I have, because the wheels just won't support it as is, being my third big mistake. And I can learn from all of this, of course. I've learned for the future to make sure that everything's planned out in advance, so I don't have things like a lip on the wrong side, or motors that are on the inside when they should be on the bottom to support it better. I've learned that I need to work diligently and go as fast as possible with my work while maintaining quality, or else I end up having to use quadruple D battery packs because I was not able to order the triple C battery packs on time due to my lack of diligence and realization. And 3, I've learned to really look into how much something can support beforehand, such as wheels or something of the sort, because obviously that did not play out as well as it could have. And then when I went and tried to tape heavily, the wheels ended up getting stuck, and it turned out that it was most definitely just a load-bearing issue. So there you have it. The Raspberry Pi Dog Monitor with all 8 of its glorious D batteries, and its functionality still partially intact, although obviously with its own problems. Thank you for viewing my project presentation and for really taking your time to hear out what I learned from this project about how I need to work better in the future, how I need to work better on projects like this in the future, and how projects like this need to work better for me in the future through my own foresight into problems of the sort. And that is all I have. Thank you for your time, and thank you, Harrisburg University, for allowing me to do this class and really hone my skills through building so much throughout the year and culminating it all into this semi-working dog monitor.